Hello, guys. Today we are talking about a very important topic, molar mass. It is very useful for chemists. But to understand how can we use molar mass, let's go back to moles. So we know that 1 mole of something is just 6.02 times 10 to the 23rd of that thing. So if I have 1 mole of bananas, it's going to be 6.02 times 23rd bananas. Same with eggs. And it works the same way as a dozen. We know that 1 dozen of something is just 12, right? So from here, let's say that I am given a task. The task is that I have to count how many extra large eggs do I have if I am given 10 kilograms of extra large eggs. But I got another information. I know that 1 dozen of extra large eggs is actually going to weigh 1 kilogram. So, do I still have to go in and count the eggs one by one, or is there any other easier way to count how many I have? There is one, right? So I know that 1 dozen weighs 1 kilogram. I have 10 kilograms, which means that I am going to have in 10 kilograms 10 dozen eggs, which is just 120 eggs. Okay, I hope this makes sense. So, molar mass works very similarly. And what's cool about it is that the molar mass of any given substance in grams per mole is numerically the same as the mass of that substance in atomic mass unit. So if I have carbon atoms and I know that its formula weight is 12, I'm going to have its molar mass given as 12 grams per mole. And the number of particles in this 12 grams is 6.02 times 10 to the 23rd carbon atoms, because I have 1 mole of it. The same works with nitrogen atoms, for example. If the formula weight is 14 AMU, my molar mass is 14 grams per mole, and I'm going to have in these 14 grams per mole 1 mole of nitrogen atoms, which is 6.02 times 10 to the 23rd. What if I have diatomic molecules or even larger molecules? Same applies. If you have N2, which is a diatomic molecule, the formula weight is 28, which is 2 times the formula weight of the nitrogen atom. So the molar mass is also going to be 28, just in grams per mole. And in this case, I'm going to have 6.02 times 10 to the 23rd N2 molecules. Okay, so let's put this into practice. Let's try to convert 15 grams of water into moles. So how many moles of water do I have if I have 15 grams of water? Well, in order to do that, I first have to figure out the molar mass of water. To do that, I need a periodic table. So I know that in water, I have 2 hydrogen atoms and 1 oxygen atom. And here's the periodic table. Let's find hydrogen first. So here is hydrogen. And what is the molar mass of a hydrogen atom? Well, it's same as its mass in atomic mass unit, right? So the molar mass of a hydrogen atom is 1.00794 grams per mole. We're going to round up a little bit. What about oxygen atoms? Find oxygen atoms in the periodic table. Do you have it? So in case of oxygen, the molar mass of oxygen atoms is 15.9994 grams per mole. We are again going to round up to 16.00. So from here, we can calculate the molar mass of water. So here, since I have 2 hydrogen atoms, I need to take 2 times the molar mass of hydrogen atoms, which is 2 times 1.01 grams per mole plus the molar mass of oxygen atoms, which is 16.00 grams per mole. So the molar mass of H2O is going to be 18.02 grams per mole. Okay, so I know that if I have 18.02 grams of water, that is going to give me 6.02 times 10 to the 23rd water molecules, right? Because that is 1 mole. But how many mole is 15 grams? Well, in order to calculate that, I have to do the following. So I know that I have 15 grams of H2O, and I want to convert from grams into moles. So I can again set up a fraction where I have to cancel out the grams of water and derive to moles of water. So the grams will go on the bottom and the moles will go on top. So I know that 1 mole of H2O is 18.02 grams. Okay, so if you do this calculation, you are going to realize that 15 grams of water is actually 0.83 moles of H2O. Okay, I hope this makes sense. Now let's calculate how many molecules and how many atoms do I have in this 15 grams of H2O. So we have to figure out the number of H2O molecules, the number of hydrogen atoms, and the number of oxygen atoms. We already know that 15 grams of H2O is 0.83 moles of H2O. So now I have to convert the number of moles into number of molecules first. So if I have 0.83 moles of H2O, I can set up again a conversion factor. I know that in 1 mole of H2O, I'm going to have 6.02 times 10 to the 23rd H2O molecules. Okay, so now if you do this calculation, you are going to arrive to 5.0 times 10 to the 23rd H2O molecules. Okay, now how do I convert from number of molecules into number of atoms? So I know that in one H2O molecule, I'm going to have 1 oxygen atom. All right, so how many oxygen atoms do I have in 15 grams of H2O? The same number as the number of molecules, right? Because the conversion factor is 1 to 1. So I'm going to have 5.0 times 10 to the 23rd oxygen atoms in 15 grams of H2O. All right, how about the number of hydrogen atoms? So in one H2O molecule, I'm going to have 2 hydrogen atoms. So how do I calculate the number of hydrogen atoms? I can simply multiply the number of H2O molecules by 2, or I can write it out nicely with a conversion factor. So if I have 5.0 times 10 to the 23rd H2O molecules, my fraction will be H2O molecules on the bottom and H atoms on the top. I know that for one H2O molecule, I am going to have 2 hydrogen atoms. So it's clear again that I just need to take the 5.0 times 10 to the 23rd and multiply that by 2. So if I do that, I'm going to arrive to 1.00 times 10 to the 24th hydrogen atoms. Okay, I hope this makes sense. So just remember that molecular mass is very, very important, and it helps us to actually count how many atoms or molecules you have in the lab. See you in the next video.